In this video, they give you the structure of acetic acid, but they give you the wrong structure of the acetic acid. They want to ask you what's wrong with it, identify what's wrong with it, and then go ahead and write the correct Lewis structure. So I'm going to redraw this structure on a nice clean sheet of paper, and then we can figure out what exactly is incorrect about this Lewis structure. So here's problem 948 where they ask you what exactly is wrong. There's several things to my eye that are wrong with this Lewis structure. First and foremost is that carbon here, 1, 2, 3, 4, 5. That's a big no-no. Another thing that's a big no-no is that double bond to the hydrogen. Hydrogen likes to form single bonds. Many things are messed up here. Remember, the goal is to minimize formal charge and to get an octet. There are ways that you can rearrange the bond so that you can get an octet, minimize formal charge. For example, the formal charge on this carbon, 1, 2, 3, 4, 5. Carbon happy at 4, 4 minus 5 is minus 1. The formal charge on this oxygen, 1, 2, 3, 4. Oxygen happy at 6, 6 minus 4 is plus 2. So there's formal charges everywhere. There's a double bond to a hydrogen. This does not have an octet. Take your pick in terms of what exactly is wrong with the structure of acetic acid. But we can draw the correct structure of acetic acid. One thing we can do here is, at least what I feel I can do to make this structure a little bit better, is I can take this lone pair of electrons here and move it out up here so that you have a double bond. The second thing I would do is, because a double bond to an oxygen is perfectly valid, another thing I would do is just get one of these double bonds out, because hydrogen only forms single bonds. So let's see if we do that, what we get. So for acetic acid, redrawing this structure where we eliminate that double bond. So now that seems good. I have a carbon with another carbon. Here I'm going to move it up here. So now I have a double bond with the oxygen. One thing I can also do here, instead of removing that double bond completely, I'll take that pair of electrons and move it to this oxygen here. Okay, so erasing it and putting those pair of electrons to this oxygen. And you can see that you have a much better Lewis structure of acetic acid. It's a better rendition of acetic acid. Number one, carbon is happy at 4. You'll have an octet, 1, 2, 3, 4, 5, 6, 7, 8, octet here. This carbon, we'll call it carbon 2, happy at 4, 1, 2, 3, 4. It has an octet 2, 1, 2, 3, 4, 5, 6, 7, 8. This oxygen compared to that one is much better off. First of all, it has an octet, 1, 2, 3, 4, 5, 6, 7, 8. Formal charge is going to be 0, 1, 2, 3, 4, 5, 6. Oxygen happy at 6, 6 minus 6 is 0. This oxygen here has an octet, 1, 2, 3, 4, 5, 6, 7, 8. Its formal charge 2 is also 0. Formal charge on this oxygen, 1, 2, 3, 4, 5, 6. Oxygen happy at 6, 6 minus 6 is 0. So there's single bonds to the hydrogen. This is a much, much better representation of the molecule known as acetic acid.